Okay, we're finding reference angles. So I'm going to use one diagram for each of these. We need to know where these angles live in terms of radians and degrees. Remember that degrees are represented with a degree symbol and the radians are not. So 150 degrees starting out at the x-axis. We go to 90 degrees and then we have a little bit more. It's shy of 180 degrees. But then we are going to be using this reference angle. So here's theta. Our reference angle is going to be there. And so in order to find that value, we're going to take that 180 degrees here minus our theta. So A is going to be 180 degrees minus theta, or 180 degrees minus 150 degrees, which is 30 degrees. So the reference angle would be 30 degrees here. For question B, we have a negative. Theta is equal to a negative 7 pi over 8. We have to think about this. Remember that negative means we are going clockwise instead of counterclockwise. Still starting at the positive x-axis. We're swinging down and we're going to go clockwise, but we are not at a full pi. So this is pi or 180. This is pi over 2 or 90 degrees. Down here is 3 pi over 2 or 270 degrees, and this is 0 or 2 pi.
Or 0 and 360 degrees.
We are not going a full pi. 7/8 is just shy of a full pi. So we are going to draw our angle out here. Our actual angle here, theta, let's call this theta 2, is equal to negative 7 pi over 8. So because I'm in the third quadrant, what I'm going to do is I'm going to take the angle measure minus
The theta value.
When we're finding this reference angle, though, we need to find,
The distance between pi and theta.
instead of using the negative version of this, I want to use the positive version of this. So what I'm going to do is I'm going to find 2 pi minus 7 pi over 8 to get the positive. So I want to calculate, first of all, what this whole thing is first, so that I can then use the reference angle idea. That means I'm going to do 2 pi, or 16 pi over 8, minus 7 pi over 8, which is going to give me 9 pi over 8. And now I can use the quadrant 3 rule of taking the angle measure minus pi. I'm going to take 9 pi over 8 minus 8 pi over 8, because that's one whole pi, which is going to give me pi over 8. And that is the reference angle that's in quadrant 3. For question C, this is radians, and this is 5. So you do want to know a little bit about pi in this case. Where is 5? It's not written in terms of pi, but you can think about where it should lie. Pi is 3.14, and 2 pi is 6.28. So where would that 5 lie? 1.5 pi is 4.71, so 5 is going to be in the fourth quadrant. This is going to be my reference angle here. Because I'm in the fourth quadrant, what I'm going to do is 2 pi minus that value, because we're in radians. And I'm going to leave it as 2 pi minus 5. You could convert that to a decimal if you want, but I think it's better to leave it as 2 pi minus 5. The last one is 13 pi over 3. I want to find the coterminal angle because that's bigger than 2 pi. So I'm going to take away 2 pi first. 6 pi over 3 is 2 pi. That gives you 7 pi over 3. Well, again, that's bigger than 2 pi. So I subtract 6 pi over 3 and I get pi over 3. So this angle, do it in red, goes once, twice, and then a little bit further. And so this is our reference angle for that last question. We didn't actually have to do anything because it was already in the first quadrant. We just had to figure that out using a coterminal angle. And I also used a coterminal angle in part B to get that positive rather than negative.
Skill practice 4 says,
evaluate the functions. Notice that this does not say use a calculator to approximate. We are going to find the actual values of this using some information that we had previously on our 30, 60, 90 triangles and our 45, 45, 90 triangles, and then finding reference angles. So let's start out with 5 pi over 6. Let's draw that and figure out what the reference angle is first. 5 pi over 6 is almost 1 whole pi, which means that is going to be going from the x-axis, swinging open to about here. Because I'm in the second quadrant, in order to find that reference angle, I'm going to do pi minus my angle. Six pi over 6 minus 5 pi over 6 gives me a reference angle for A of pi over 6. Now remember, pi over 6 is the same thing as 30 degrees, and our 30, 60, 90 triangle, we were able to evaluate sine, cosine, tangent. So let's draw that 30, 60, 90 triangle again. Remember that 30 was a smaller angle and it was opposite a ratio of 1. 60 had root 3, and the right angle was a 2. And so when I'm trying to figure out the cosine of this 30 degree angle, it's going to be adjacent over hypotenuse, or root 3 over 2. However, where am I? I'm not in the first quadrant. I am in the second quadrant. So here I am. And in the second quadrant, I have negative x's, I have positive y's, and my r is always positive. And so my
angle of 30 degrees in quadrant 2 then has an opposite of 1, an r value of 2, and an adjacent side of root 3. But in the second quadrant, the x is negative, so that is a negative square root of 3 over 2.
if you look back at the chart in the second quadrant, you know that x's are negative. Cosine has to be negative, so you would just assign that value. For part B, we have negative 120 degrees. And we're doing the cotangent, which is going to be adjacent over opposite. Negative 120 degrees goes clockwise, so we're starting from the fourth quadrant, past the y-axis, into the third quadrant, where both x and y are negative. We draw our triangle here. And so our reference angle is going to be this distance here from that negative 120 up to the horizontal axis. And so if we take in the quadrant 3, we take the angle minus 180, we're going to get into a negative here. So negative 180 minus 120 is going to give us negative 300. But negative 300 has a coterminal angle of 60 degrees. So this distance right here is 60 degrees. And so we're going to be using, again, that 30, 60, 90 triangle. And so for 60 degrees, opposite the 60 is root 3. So this is a side length of root 3.
The hypotenuse has a value of 2, and the adjacent is a value of 1.
And so when I'm doing cotangent for theta, I'm doing adjacent over opposite. So I'm going to be saying that the cotangent of negative 120 degrees is equal to 1 over root 3, which I rationalize, and I get root 3 over 3. For part C, cosecant, reciprocal of sine, is going to be hypotenuse over opposite. And we're going to find that reference angle. 7 pi over 4 is almost 2 pi because it's almost 8 pi over 4. So I'm going to go all the way around past 3 pi over 2 here. That angle is 7 pi over 4. And so we need this reference angle here.
In the fourth quadrant,
So what I'm going to do is take 2 pi minus that angle of 7 pi over 4 to find the reference angle. 2 pi written with a common denominator is 8 pi over 4 minus 7 pi over 4, which is just pi over 4. Pi over 4 is the same thing as 45 degrees, and so we can use that 45, 45, 90 triangle with those ratios to help us solve this. So drawing my triangle, the length of the sides are 1 and the hypotenuse is root 2. So taking cosecant of 7 pi over 4, that's the same thing as cosecant of pi over 4 in the fourth quadrant where x is positive and y is negative. Cosecant is 1 over sine. Again, like we said, that's going to be hypotenuse over opposite. And so that's going to be root 2 over 1, or just root 2. However, fourth quadrant, the square root of 2 is positive, but the 1, which is the opposite, is negative. I should have written that negative right there. So that means that that's a negative root 2. Skill practice 5, evaluating the functions. We have 11 pi. We're going to do the cosecant of 11 pi. Where is 11 pi? It's a multiple of pi. So that's going to be somewhere on an axis. We have 0 and 2 pi here. We have pi over here. So if I start and I go, one full revolution is 2 pi, another is 4 pi, another is 6 pi, another is 8 pi, another is 10 pi, and then 11 pi is one more rotation. What I just did is I found the coterminal angle as just being pi, but you could take away 2 pi a bunch of times to find that the coterminal angle is pi, because it's between 0 and 2 pi. And pi is where we have a negative x and 0. So when we're trying to find cosecant, remember in this case, r is equal to the square root of x squared plus y squared, or r is equal to the square root of x squared, meaning r is just equal to x. The cosecant of 11 pi, remember that cosecant is 1 over sine. And in this case, when we're talking about obtuse angles, we're going to be using the y over r for our definition rather than opposite and hypotenuse, because we're not talking about a right triangle. And so this is going to be 1 over the y over r, or r over y. And so cosecant of 11 pi is equal to r, which is x, over y. And in this case, ry is 0. So this is undefined. For cosine of negative 600 degrees, let's find that coterminal angle. We're going in reverse. So that's going to be one full revolution is negative 360 degrees. So if we add 360, that's going to give you negative 240. So we're not going to go completely around again, but we're going to go 180 and then a little bit further. And so we need to figure out what this reference angle is to be able to calculate. So this negative 240 means that we're dealing with 120 degrees here. Taking 180 degrees minus 120 degrees, we get that that reference angle is 60 degrees. And again, we know the values for 60 degrees based on the 30, 60, 90 triangle. Opposite the 60 degrees is the root 3.
Adjacent to 60 degrees is 1.
The r value for that specific triangle is 2. And so when we're finding the cosine, that's going to be adjacent over hypotenuse. And in the second quadrant, remember that the x is negative and the y is positive. The cosine is going to be adjacent, which is negative 1. Over 2, or negative 1/2. Skill practice 6. Given cosine of theta is equal to negative 3/8 and sine is less than 0, find the sine and the tangent. So we have to do a few things here. We need to draw out what this triangle looks like and determine what quadrant it's in. Cosine is negative. Well, cosine is going to be x over r. So this is when x is negative. And whenever cosine is negative, then x is also negative, because remember, r is always positive. And x is negative in the second and third quadrants. But they tell us that sine is also negative. So for the sine of theta, which is y over r, to be negative, y has to be negative. And y is negative in quadrants 3 and 4. So for both cosine and sine to be negative, that has to happen in quadrant 3. So we are in quadrant 3 here. Drawing out theta, and remember it's always from the horizontal axis. Our hypotenuse is 8. Our adjacent is -3, and we need to find what our opposite is. So we're going to use the Pythagorean theorem for that. Remember that r squared equals x squared plus y squared based on the Pythagorean theorem. So we have r, which is 8. 8 squared equals -3 squared plus y squared, or y is equal to the square root of 8 squared, which is 64,
minus 3 squared, which is 9.
and the square root of 64 minus 9 is root 55, which does not have any perfect squares inside. So that y is negative root 55. Finding the sine is equal to y over r, which is negative root 55 over 8, and then tangent is equal to y over x, or negative root 55 over -3, which becomes positive root 55 over 3.